Hey all, in this video, I am going to review confidence intervals and how we can calculate a confidence interval, as well as how we can interpret a confidence interval appropriately to explain what our interval values mean. And we are going to start with a discussion about, and again, if you've watched the previous videos, I'm new with this program, so I keep making some mistakes. So hopefully you get a laugh at that. I'm going to start with a confidence interval for means. And so this is the Chevy Aveo we talked about a long while ago. And we said that we had a random sample of 50 cars. So that is an N value of 50. That's probably not a great color to use. That makes it look worse. And they had a mean and average time on a lot of 54 days. This is a sample. So if you've watched the previous videos, we've used the Greek letter mu to talk about average. Well, now we have a sample average, which is X bar. So they've been on the lot an average of 54 days. And we have a standard deviation S, because it comes from a sample, of 6 days. And so we want to find a 95% confidence interval. When we talk about a point estimate, that is one estimate for the actual average amount of time that these Chevy Aveos stay on the lot. Well, that would just be our sample average. So this 54 days is our point estimate. That's the best point estimate we have here. It's just one estimate for what the actual average could be. It's probably not right. So that's why we'll build an interval. And so our intervals for means looks like this. And I'm going to go back and correct myself because this is incredibly important. We are given the population standard deviation, which is still sigma. And that's going to make a big difference because when we have the population standard deviation, keyword population standard deviation, we are going to use Z star, if you remember that. And that sigma over root n should look similar to what we used when we did the central limit theorem and we needed to find a area under the curve. So we have most of this information. We have n, we have x bar, we have sigma. We need z star. And z star, if you remember, comes from some normal distribution stuff. I'm just going to give you the calculator operations. We're going to tell the calculator we have a normal distribution. And we're going to leave those parentheses blank. And then we're going to tell it, hey, we're doing the inverse of what we normally would do, which means instead of telling it some numbers and asking for area, we're going to tell it an area and ask it for a number on the horizontal axis. So we don't want to tell it 95% of the area because we're talking about area in the middle of our distribution. So when we talk to Desmos, we have to tell it this middle 95% or 0.95 plus this little area in the tail, which is half of what's left over. So if 95% is in the middle, what's left over is 5%. Half of that is 2.5%, which is 0.025. So when I plug in here, I'm going to plug in 0.975. I'm going through this really fast because it's meant to be review. And I also don't want to make these videos too long for you. So if you need help with this, please, 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 please ask me. If you type this into Desmos, it's going to give you 1.95 something, and that we will round to 1.96. And that is our Z star value. So now we can go plug all these numbers in to our formula. So I have X bar is 54 plus or minus. That means we're going to have to do this calculation twice, once with plus in the middle and once with minus. Z star is 1.96. We're going to do sigma, which is 6 over the square root of n, which is 50. And now we're going to go to Desmos, and we're just going to type all of this in with one time with the plus, and then all of this with the minus. So I'm going to pause here and actually do that and spare you watching me type into Desmos, but you should do it as well to make sure that you can get the same answer. Okay, so you should get these two numbers. We always put the smaller one first, so that's what we get from the subtraction part. We always put them in, they look like coordinates, but we put them in parentheses, and that gives us an interval. So when we ask for a confidence interval, there it is. And then we're going to go and we are going to explain what does this interval mean. And I'm going to type, again, to spare you watching me handwrite it all. And we write this formulaically. We don't get creative, if you remember. I'm going to say I am, I always am, and then how confident I am. I'm 95% confident that, and we're talking about the true mean, because we've just estimated the mean by getting 54 days, but we want to know the true mean. I'm 95% confident the true mean, and then what is it we're finding the mean for? The mean time a Chevy Aveo stays on a, what do we call it, a dealer lot, is between. So we're saying how confident we are. What are we confident about? We're confident about the mean. What mean of what? How long a Chevy Aveo stays on a dealer lot, and then we tell what our interval is. It's between 52.34 days and 55.66 days. And you could probably round that to 52 and 56 if you wanted to. So if you remember, I went back and I was adamant about correcting this symbol from S to sigma because we had the population standard deviation. The one thing that changes when we don't have the population standard deviation is that we are no longer going to use Z star. We're going to have to use T star. So let me do an example of that. Please excuse the bells in the background. So our interval is going to look similar, but instead of Z star, we had T star with that little subscript of n minus 1. And then we have S instead of sigma, but we still have root n. That n minus 1, remember, was degrees of freedom. And that's something we're going to tell the calculator when we're trying to calculate this value. And it's really just the sample size minus 1. And so we'll go through and document. We have an average X bar of 42 degrees on Thanksgiving Day. And they're giving us a sample standard deviation. That's the important keyword, sample. If it's population, you use Z star. If it's sample, you use T star. So if we have a sample standard deviation of 8 degrees, we're going to go ahead and need T star. Our sample size is 12 Thanksgiving days, N is 12. And so that N minus 1 that we would put here is 12 minus 1, or 11. And then we got to go ahead and find this value. And I think that's the only real difference here, is finding this value, T star with 11 degrees of freedom. In the calculator, you're going to tell the calculator, we don't have a normal distribution anymore. We have a T distribution. So we'll say T dist. It's going to prompt you for the degrees of freedom. You just type 11. You're going to put a period, and then we're going to do that inverse CDF again, because we're not looking for an area. We want to tell it an area, and we want it to tell us a T value, which is on the horizontal axis. So 95% confidence. Again, we're going to plug in that 0.975. If you struggle with that, please ask me so that you don't make that mistake. And I will do this in Desmos this time just so you see it. So we're going to tell it we have a T dist. See, it prompts us for the degrees of freedom. We have 11. Then we're going to tell it area is 0.975. It shouldn't be the same as Z star for 95% confidence. It's going to be different because we have a T distribution. So our T star is going to be 2.2. And I don't really know why it's not writing. There we go. Just a little bigger. 2.2. So then we could just go in and we can plug in all these numbers like we did on the previous problem. And like I did on the previous one, I'm going to go ahead and calculate this. I'm going to pause and spare you watching me calculate it. You should calculate it on your own. Check back with me for your answer. So we got decimals, but I rounded them to 37 and 47. And then I am going to type my conclusion. Again, I am 95% confident. The true mean, we're talking about mean. And then we'll say high temperatures for Thanksgiving is between 37 degrees and 47 degrees. Always saying how confident we were, what parameter we're confident about. Is it a mean or a proportion, which is the next lesson or the next review. Give the context, the average what or the proportion of what, and then give your interval. So one little sentence right there. No need to be creative. Make sure you do these practice ones. Make sure you ask me for any help that you need on the practice or on this review. Take your time and good luck.